What if everything you've ever learned about gravity isn't the whole story? For more than 300 years, gravity has been one of the most trusted laws in science. It keeps our feet on the ground, the moon in orbit, and entire galaxies bound together across billions of light years. From Isaac Newton to Albert Einstein, scientists believed they had uncovered one of the universe's greatest secrets. But now, something extraordinary is happening. NASA's newest space telescopes and cutting-edge missions are revealing strange discoveries that don't completely fit our current understanding of gravity. Galaxies are behaving in unexpected ways. Invisible forces seem to shape the universe. And the deeper scientists look into space, the more mysterious gravity becomes. Could dark matter really exist? Or are we standing on the edge of a scientific revolution that could rewrite the laws of physics? In today's video, we'll explore NASA's latest discoveries, uncover why they're shaking the foundations of modern science, and discover how one of the universe's most familiar forces may actually be its greatest mystery. So sit back, relax, and prepare for a journey across space and time, because what you're about to discover might completely change the way you see the universe forever. Imagine waking up tomorrow to a headline that reads, "NASA has discovered something that doesn't fit our understanding of gravity." At first, it might sound like another exciting space headline. But then scientists around the world begin saying something even more astonishing. If this discovery is confirmed, we may need to rewrite parts of modern physics. Gravity is one of the most familiar forces in the universe. It's the reason you stay on the ground. It's why the moon orbits Earth. It's what keeps the planets circling the sun and holds galaxies together across billions of light years. For centuries, gravity has seemed like one of nature's most reliable rules. First, Isaac Newton described it as a force pulling objects toward one another. Then, more than 200 years later, Albert Einstein completely transformed our understanding by revealing that gravity isn't really a force at all. Instead, it's the curvature of space and time caused by mass and energy. Einstein's theory has passed every major test for over a century. It predicted black holes before anyone believed they existed. It explained why Mercury's orbit behaves strangely. It even predicted gravitational waves, tiny ripples in space-time, which scientists finally detected in 2015. So how could anything challenge such a successful theory? The answer lies deep in space, where NASA's newest observatories are revealing a universe more mysterious than anyone imagined. Tonight, we're exploring why NASA's latest discoveries are forcing scientists to ask one of the biggest questions in modern physics. Do we really understand gravity? A force we experience every second. Gravity feels ordinary because we've lived with it our entire lives. Drop your phone. It falls. Throw a ball. It comes back down. Jump into the air. You always land. It seems simple. But gravity is actually the weakest of the four known fundamental forces. A tiny refrigerator magnet can easily overcome the gravitational pull of the entire Earth on a paper clip. That sounds impossible. Yet it's true. So why does gravity dominate the universe? Because unlike the other forces, gravity never switches off. Every object with mass attracts every other object. Planets, stars, galaxies, even you. Although these attractions are incredibly small, they become enormous when enough matter gathers together. Gravity slowly built the first stars. It shaped galaxies. It assembled planets. Without gravity, the universe would still be a nearly uniform cloud of hydrogen and helium. Everything we know exists because gravity patiently built it over billions of years. Einstein's greatest insight. Imagine placing a heavy bowling ball on a stretched rubber sheet. The sheet bends downward. Now roll a marble nearby. Instead of moving in a straight line, the marble curves toward the bowling ball. Einstein suggested something extraordinary. Space and time behave similarly. Massive objects bend the fabric of space-time itself. Planets aren't being pulled by an invisible force. They're simply following the curved paths created by the sun. It's a beautiful idea. And for over 100 years, every major experiment has agreed with Einstein. But the universe keeps presenting puzzles. NASA begins seeing something strange. Modern telescopes don't simply take beautiful pictures. They measure invisible radiation. They detect infrared light. They observe X-rays. They study distant galaxies formed shortly after the Big Bang. And that's where unexpected mysteries began appearing. Some galaxies rotate far faster than they should. According to gravity as we understand it, these galaxies should fly apart. Yet they remain perfectly stable. Something invisible appears to be holding them together. Scientists call this invisible influence dark matter. But despite decades of searching, nobody has directly detected a dark matter particle. This creates an incredible mystery. Either most of the universe is made of an invisible substance, or our understanding of gravity is incomplete. Both possibilities are astonishing. The James Webb Space Telescope changes the conversation. When NASA launched the James Webb Space Telescope, astronomers expected to see the early universe in unprecedented detail. What they didn't expect was how surprising those observations would become. Webb began observing galaxies that existed only a few 100 million years after the Big Bang. Many appeared surprisingly large, surprisingly bright, surprisingly well organized. According to many existing models, galaxies shouldn't have grown this quickly. Yet there they were, fully formed far earlier than expected. This doesn't automatically mean Einstein was wrong. Far from it. But it does mean scientists must ask whether their models of gravity, dark matter, and galaxy formation are missing important pieces. Every unexpected observation becomes another clue in one of the greatest scientific investigations ever undertaken. The hunt for invisible gravity. Suppose you're walking through a forest after a snowfall. You don't see any animals, but you notice footprints everywhere. Even though the animals remain hidden, the tracks reveal they were there. Astronomers use the same logic. They cannot directly see dark matter, but they observe its gravitational footprints. Light bends around invisible regions. Galaxies rotate unexpectedly. Clusters of galaxies behave as though enormous hidden masses surround them. NASA has mapped these effects with remarkable precision. Yet the invisible object creating them remains elusive. Some physicists believe dark matter is real. Others wonder if gravity itself behaves differently across enormous cosmic distances. If that's true, then the biggest discovery may not be a new particle at all. It could be an entirely new understanding of one of nature's most fundamental forces. A universe full of questions. Science rarely advances by proving everything we know is wrong. Instead, it advances by discovering that reality is richer than we imagined. Every new telescope reveals deeper mysteries. Every observation raises better questions. Perhaps gravity works exactly as Einstein predicted. Perhaps dark matter truly fills the universe. Or perhaps future discoveries will reveal something none of us has even imagined yet. Whatever the answer turns out to be, one thing is already certain. NASA's latest discoveries are pushing the boundaries of human knowledge farther than ever before. They remind us that the universe is still full of mysteries waiting to be solved. And somewhere among those mysteries may lie the next great revolution in physics.